Alright, we got take two at this. My audio didn't record last time. So this is my program. I'll try and zoom through it. So this is a Sudoku game. You can basically just play Sudoku on it. I'll go ahead and show you right now. Let's say I want to play a medium game. It'll show me a board with a moderately amount of items, and I can add a number. Oh gosh, that's something I gotta fix. Let's say I want to add a number, so let's say 1, 2, 3, 4, 5, 6. So 1 and 7 need to go in here. I can see the 7 can't go there, so let's try and add it there. So row 1, column 3, let's stick a 7, and it's an invalid move. It does not exist. So let's try adding the right number there. So let's add number 1 there, and it works. And let's do the same thing with the 7, and it all works. So that's essentially the program. You can just play Sudoku. Once you complete the board, you'll win the game, and I'll show that to you here. This is where it all starts here. Just some instantiated variables, and this is set to false because there is no valid board. And while the board isn't valid, it'll basically just generate a board, which I'll get into all the outside functions later. But it generates the board, and then if it is a valid board, then it'll continue. If not, it'll just reinstantiate a class with a new board until it's valid. So with that, now we get the player's difficulty. So they say, okay, which difficulty do we want to play? 3. Okay, so it'll set the difficulty to 3. It'll set up the board based off of that difficulty, and it'll print the board off to them. And then it will start playing the game. So the game is set with a bunch of values here. Valid row, column, and number are all just set to a false value every time, while they have no valid move. But that'll change whenever they make their choice. So let's say they choose 1. This is where they insert a number. So they're asked to enter a valid row. This will just basically safe check whether or not the row was a valid number, and it will keep asking them. Same for the column and number until they enter a valid number, and then it will check whether or not the move they did was valid, and then it will check, if not, it'll just input all their errors into this errors variable. And then if it was valid, it would add the number to the board and print the new board to them. So that's the essentialness of this part. And then if they decide to remove a number, it's the same thing as this, except they only input the row and column, and then it will just remove it. No questions asked. So that's roughly the majority of the code. And then, of course, if they choose to quit the game, it'll break the loop right here. Playing is equal to false, which will break the while loop. Since all the previous loops were broken, it just ends the game. And then we can start getting into the other functions here. So the winning board checker is basically just ran at the end of the program where it says, okay, this board's valid, and it equals it to 0. So anytime there's a 0 is basically just inputting an empty variable. So that's where you see all of these empty squares. These are just zeros. And it checks whether or not that's a 0. If they're all filled, then you've completed it, because it won't let you input an invalid number. So this will be generated, and this is the cell checker. In here we have the generate board, which is where the board itself is generated and all that stuff. So it iterates through the rows and columns of a Sudoku, so just 1 through 9. And then it'll generate a random number 1 through 9 and basically just check whether that is a valid Sudoku move. So that's where all these functions come in. So it'll check the vertical, it'll check the horizontal, and it'll check the cell that it belongs to. So when it's checking, it's say, okay, this 2 can go here, this 2 can go here, and this 2 can go here. So therefore, it's a valid move. So that's what all of these are doing here. And that's the essentialness of the program. And then we've got the add and remove num. This is just called whenever the player wants to add a number or remove something. If they made a mistake and can't go back, they've got that failsafe here. The print board function is just formatting it in a way to show the board in a fancy way. There's nothing too special. Like adding a number, it'll check whether or not you're in a row. It'll check whether or not you're in a column. So it'll do that nice and neat. And then the find row column, some of these are, repeated names, but essentially the find row column is dependent on the board setup. The board setup essentially calls the difficulty, and then it will run those values through. Whoops. it'll send those values through to here. And basically it's just saying, okay, we know how many cells to show. That's what these are. These are how many cells do we want to show in this difficulty. And then what it will do, it'll basically find those values. It'll randomize the board and it'll place them scattered around the board. And it will find the row and column of that item, and then it'll basically just make that value equal to that item. So let's say it gets 1, 2, 3, and it shuffles to 3, 1, 2. It'll grab the third cell and make it equal to this. So basically just grabbing random points on the grid. And that's what this does as well. This basically just grabs that information for us. So we get that, and that's roughly the majority of the code. The check valid board is just used when instantiating the generated board. It just determines whether or not the board that was generated is valid. There's no blank spots. And then the check valid move is doing roughly the generate board structure here, except it's passing through the player's board. It's basically just checking whether or not the move they made is valid. So that's roughly everything. Yeah, again, this is what it looks like if I were to go in possible mode. Yeah, so that's roughly the program that I've got here. I had a lot of fun making it. So yeah, that's it.